What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 8.2, proving triangle similarity by AA, or angle, and we'll be able to solve real life problems with those things. First thing we're going to do is switch gears and look at our theorem sheet. We're going to start with theorem 8.3, which is the angle similarity theorem. That just states if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. The reason why we don't have to have angle is because by the time you've already decided if these first two angles are equal, then the third one should match, because all triangles have to have 180 degrees and then they'd be using the same two angles for that measurement. So what we're going to look at here is show if the triangles are similar, write a similarity statement. So the first one, we can just look at FGH and RQS. That means I'm going to maybe focus on FG matching RQ, noticing that F and G and R and Q all have one arc. So I know that angle F is congruent to angle R, and angle G is congruent to angle Q. So triangle FGH is similar to triangle RQS. Over here, if I look at triangle CDF and DEF, I would maybe say, first I want to know what are the missing degree measurements. This one is going to be 58 in this corner, and the missing degree measurement for letter D up here, so that would be just 58 plus 90 is 148, but then if I subtract that from 180, my remainder is 32, so angle D, FDE is 32 degrees, which means this top angle here is 58 degrees, okay? So using the triangle sum theorem, we can find those missing angle measurements. And I just want to see, is CDF matching DEF? So I'm going to start with angle C. Angle C has to match angle D in that first one, and angle C does match angle D because they're both 32 degrees. And angle D, notice it's the second in line, has to match angle E. Angle D is 58 degrees in the first triangle. Angle E is also 58 degrees in the second triangle, so we can also say angle D matches angle E. So triangle CDF is similar to triangle DEF. So the important thing here is just to keep in mind what order do the angles match up. So C has to match with D, D has to match with E, and then F has to match with F. Okay? This next one, determine whether the triangles are similar. If they are, write a similarity statement, explain your reasoning. So again, using that third triangle sum theorem, I'm going to take 21 and add 99, I get 120, and then subtracting 120 from 80, I'm going to get 60 for letter Y. So this one, it probably is not going to match up. This one I have 21, 61, that gives me 82. Subtracting 180, I'm going to get 98 for angle S. And I don't have two angles that I can match up, so there's only one pair of congruent angles where AA needs two pairs. So no, not similar. Okay. Next up, a school flagpole casts a shadow that is 45 feet long. At the same time, a boy who is 5 feet 8 inches tall casts a shadow that's 51 inches long. How tall is the flagpole to the nearest foot? So it's now that we're using some problem solving. So here's our flag waving in the wind, and the shadow is 45 feet long. And then it says here is a boy. That boy is 5 foot 8 inches. Which is, in inches term, we want to be able to say like 68 inches. So it would probably be best to change this to inches as well. So 45 times 12, 540 inches. And his shadow is 51 inches long. So we're just looking at how tall is the flagpole. Well, we can use this as a proportion. X over 540 inches represents my flagpole, and 68 inches over 51 inches represents the boy. We would cross multiply 540 times 68. I'm going to get 36,720, then divide that by 51. I'll get 720 inches, which if I divide that by 12, is 60 feet tall for the flagpole. Okay, that is actually going to conclude our lesson on 8.2. So we just talked about basic things of proving those angles and then also applying similar figures to real world problems like this one shown. Hopefully this video helped you. If it did, give it a thumbs up, and we will catch you next time when we look at more proving with triangle similarity, but now we'll look at side, 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 and side angle side. Have a great day, geometry.